Hello and welcome to this BTEC Sports Science screencast on antagonistic muscle pairs. Also going to be looking at the different types of muscular contractions we have, because these are the type of questions we may be given in our exam. We have a 6-marker here. Analyse the antagonistic muscular contractions, so we need to know about antagonistic pairs and muscular contractions used to perform both the upward and downward phase of the press up. So at the end of our lesson, we're going to be able to answer this. At the end of this screencast, we're going to be able to know what antagonistic muscle pairs are and the different types of contractions we have, as well as what muscles create what movements at specific joints. So we need to know all this because we also get this at the very end, we get this 14 marker at the end. So this picture shows a tennis player completing a forehand shot. The right arm and right foot have been shaded. Analyse the required movement at the elbow, ankle and shoulder. So we have to be able to identify what type of joint it is, the articulating bones of that joint, what movement is taking place from preparation to execution, what muscle has created which movement, which muscle is the agonist, which muscle is the antagonist, as well as saying what plane of movement this takes place in, as well as the muscular contraction type taking place. Now that seems like a lot. However, by the time we've gone through this screencast, by the time we've done a few kind of retrieval strategies within lesson, this is going to be straightforward for the majority of you. First of all, this is what our corner notes are going to look like. Our first set of corner notes are going to look like. We need to know what the agonist is, what it means. We need to know what the antagonist means, synergist and fixator. So, first of all, muscles work in pairs. One muscle works whilst the other muscle relaxes. The muscle that works is known as the agonist, okay, and this is known as the prime mover. The agonist is a muscle responsible for creating movement at a joint. The antagonist relaxes and opposes the movement of the agonist. Okay, so for example, in a bicep curl, if we look at this picture, during a bicep curl, the agonist, the muscle creating the movement, is the biceps. As you can see, the biceps inserts here on the lower part of our arm, on our radius and our ulna. So when we flex the elbow, the biceps causes elbow flexion. It's the agonist, whilst the antagonist opposes the agonist, and that is the triceps here. Antagonistic muscle pairs, so muscles work in pairs, they're opposite each other. Okay, so when the bicep works, the tricep relaxes. When the tricep works, the bicep relaxes. We also have these muscle groups called synergists. Now, synergists are muscles that work together to enable the agonist to operate more effectively. So really, the synergists are kind of like muscles just around this area. So brachioradialis, for example, or we can have teres major, teres minor. The fixator, however, is simply the muscle that stabilizes part of the joint. So fixes the joint. Think fixator, fixing, fixes, stabilizes. So stabilize the joint. For example, at this picture now, bicep is the agonist during elbow flexion, tricep is the antagonist, the fixator would be the deltoid, just fixing, stabilizing the shoulder joint during that movement. So they're the kind of like key terms. We need to just know which muscle is the agonist, which muscle is the antagonist during specific movements, which we're going to go through now. So we are going to go through the main shoulder movements that you're going to potentially be asked for in an exam. So I want you to split this into kind of like a table where you have shoulder, and then underneath you have the different movements as well as the agonist and antagonist. So shoulder flexion, agonist anterior deltoid, antagonist posterior deltoid. Remember, they're opposite each other. Shoulder extension, therefore, the agonist is posterior deltoid, the antagonist is anterior deltoid. If you know the one, you know the other because they just switch around. Shoulder abduction, the agonist is the middle deltoid or medial deltoid. The antagonist, opposite, is the latissimus dorsi. They're opposite each other. So latissimus dorsi. And you guessed it, shoulder adduction. The agonist is latissimus dorsi. And the antagonist is the middle or medial deltoid. So these are the main movements of the shoulder. We've got one more, horizontal flexion. The agonist is pectoralis major. The antagonist opposite that is the trapezius on the back. Therefore, horizontal extension, agonist is trapezius, antagonist is pectoralis major. So in this picture, this arm has moved backwards, parallel to the floor. So that's the shoulder. If we go down to the elbow, so movements agonist and antagonist. Elbow flexion, agonist biceps, antagonist triceps. Therefore, elbow extension has to be agonist triceps brachii, antagonist biceps brachii. Trunk movements, so trunk flexion, agonist rectus abdominis, antagonist erector spinae. So therefore, trunk extension, agonist erector spinae, antagonist rectus abdominis. Trunk rotation, external obliques is the agonist, the muscle that works. The antagonist, the muscle that relaxes, are the internal obliques. If we go on to the hip flexion, the agonist is iliopsoas or rectus femoris. The antagonist, gluteus maximus. Therefore, hip extension, agonist gluteus maximus, antagonist iliopsoas or rectus femoris. Hip abduction, abduction taking away, gluteus medius, it's on the side of our body. If the side of our body is a body part that moves, or we move the body kind of laterally, it's going to be a muscle on the side. So gluteus medius is the agonist, adductor longus is the antagonist. Therefore, we won't need to know hip adduction. Sorry, is a movement, never gets asked. Knee movements, knee extension, agonist rectus femoris, i.e. the muscle that causes knee extension is rectus femoris. Antagonist biceps femoris. Knee flexion, agonist biceps femoris, antagonist rectus femoris. Last joint ankle movements, looking at the agonist and the antagonist. Plantar flexion, the agonist is gastrocnemius. You can see plantar flexion taking place at the ankle. You can see that the muscle here is clearly working under tension. So the agonist gastrocnemius, antagonist tibialis anterior. Dorsiflexion, agonist tibialis anterior, antagonist gastrocnemius. So, what I want to talk about now are types of skeletal muscular contractions that we have. So we need to be aware of the type of muscular contraction: concentric, eccentric and isometric. So concentric contraction is when the muscle shortens under tension. An eccentric contraction is when the muscle lengthens under tension. And an isometric contraction is when a muscle contraction or the muscle stays the same length under tension, so it does not move. Think of eccentric, think elastic, think of elastic band. When you stretch an elastic band, it lengthens. Eccentric lengthens under tension. Isometric contraction stays the same length under tension. Isometric, M stands for movement, however it's one with no movement. A sporting example of an isometric contraction would be a headstand, no movement taking place. The crucifix in gymnastics in the rings, when you're holding yourself in that crucifix position using the rings, that is an isometric contraction, no movement taking place. A plank, no movement taking place, that is an isometric contraction. So here, concentric, shortens under tension. Eccentric, lengthens under tension. Isometric stays the same length under tension. Please make sure you have good notes on this. It's really important. It really is important, especially when it comes to that last question for you to get 14 out of 14. So thank you for listening, and I'll see you soon.